Now, everyone.
هاي كوثر نسمعك.
Can you hear me?
Yes.
So I think the guest is here. So welcome everyone. I hope you're doing well. Inshallah, today is the fourth episode of MDS Talks, and we are going to host the Zaid Ahmad Awan. If you are really a loyal viewer of MDS Talks, you would have known that the first ever episode done by MDS Talks, it was in Google Meet, and the guest was the same guest today, Zaid. So that day something really funny happened. I remember that on the Meet, like someone entered the Meet and started to distribute the organization. So we didn't continue on the same style, and we started streaming on YouTube. And this is pretty much how MDS Talk started. So today we are again with Zaid. And inshallah, we're going to talk about a very important topic. And actually, this talk is not going to be just simple session. It's going to be a workshop. So I would love you to be ready, like use your laptops instead of your phones if you are connected with your phones. And we are going to discuss the optimization of LLMs and fine-tuning adapters with the advanced LLMOps. So I don't know if you can hear me. Welcome
yes,
again.
I can hear you. Thank you.
So yeah, that's pretty much it. So you can start. Thank you, first of all, for joining us today.
Sure,
and yes,
thank
with
you.
And for all the participants, I would love you to be interactive. So if you have any questions or anything to add, please raise your hand at the very end. We'll have like a Q&A session. So yeah, you can go.
Thank you very much. Thank you, Esma. Thank you, everyone. So let me share my screen so we can start quickly. So please let me know when my screen is visible to you guys. My screen is visible, right?
Yes.
Yes. Yeah.
Okay. So let me start with my quick introduction. So most of the people know myself. I am working as a lead machine learning engineer in a US-based company. So I have around 6 years of experience in data science, ML, and data engineering and data analytics. So from last couple of years, I've been working with generative AI since the boom of this generative AI and large language models. So I've been doing multiple things like I started with a simple RAG applications where we were trying to build some simple RAGs and some complex RAGs for multi-turn conversations and for simple conversations, for documents search and for web search, etc. So I've been using multiple agentic frameworks as well. So I used Crew AI, LangGraph, and some other agentic frameworks like AutoGen as well. So today's topic is all about fine-tuning large language models. I mean, why it is important to fine-tune the large language model and what are the techniques to fine-tune a large language model and how we can use how we can use the resources or optimally, like if you have one GPU or if you have a smaller GPU with maybe 40 gigs of VRAM or 80 gigs of VRAM, or if you have multiple GPUs. So what are the optimal approaches to fine tune a large language model? This is what we are going to discuss, and we are also going to discuss the need of fine tuning a large language model. I mean, after all, why we have to fine tune a large language model. So let's start with the quick introduction. of generative AI project lifecycle. So I'm not sure if I have shown this life cycle in my previous session as well, but we can reiterate on this life cycle. So just like we have life cycles in software engineering and other and conventional machine learning, where we have like crisp DM type of cycle. So we have to define a use case, and then we have to find the relevant data set for that particular use case. Then we have to perform some kind of data munging or data pre-processing on top of that, so we can feed that data to our model for the training. And once we are done with the training, so we have to evaluate the results by using our validation data set or our test data set. So that is not the only validation which we do. So normally we do the test and validation data set, validation by using test and validation set, and we also do the validation by using the real data set after that. And then we evaluate those results, and then we try to optimize those results. So let's say if we are not getting good accuracy, or if we are not getting good results, so we have to optimize our model. So this is an iterative process. So we iterate over and over again. So maybe in 2 or 3 or 4 or 5 cycles, we can come up with a good model. And once we decided that the model is good enough for the production, so we go with the deployment part. In large language models, so we have this life cycle where we have to define the scope. So this scope is nothing but uh, exactly similar to the business use case which we define in data science or machine learning. So we have to define the scope, we have to define the use case, we have to be very, very clear related to our requirements. So for example, let's say you want to build a chatbot for multi-turn conversations. So when I say multi-turn conversations, it could be anything. It could be for your contact center conversation. It could be like for your help center. It could be customer care purpose. So it could be anything, right? So you have to define your use case first. So let's say for this workshop, my use case is, let's say my use case is for multi-turn conversation. So I have to use a large language model which I can use for my customer care center, right? So when I say customer care center, so you guys have already seen some NLU based, natural language understanding based uh, chatbots, which are providing you a very static type of responses upon asking a question. So let's say you are a logistics company, and you are sending you're sending some kind of things from one location to another location, and then you want to track your order. So you go to the chatbot and you start asking question, hey, what is the status of my order? So where is my shipment right now, right? And those chatbots will provide you a static type of responses. So in case of contact center, let's say if you're a service providing company and you have a contact center, and you purchased a package from that company related to something like internet package or maybe a call package, and you're not satisfied with your package and you wanted to cancel your line, let's say. So you reach to your contact center and you say, hey, I want to cancel my line, right? But the good agent will always try to retain you. The good agent will always try to make sure that you don't churn. So customer churn is a very sensitive use case in many telecom sectors and contact center sectors. So the good agents, so when I say agent, so it means there could be a human agent in the contact center. There could be hundreds of agents. So some of the agents are categorized as a good agent. So the good agent will always try to retain you, right? So the good agent will try to understand your issue. So why you wanted to cancel the line, what is the purpose of this line cancellation, and he or she maybe will try to offer you some kind of packages like, hey, I can, cut the cost, I can do this for you, I can do that for you, I can offer you a package, I can offer you a combo deal, I can offer you a BOGO deal, buy one get one free type of deals. So the ultimate goal will be to retain the customer, right? So we have to define the scope, what we wanted to achieve by using large language model. So as you know, these large language models are trained on large corpus of the internet dataset. So this step is called pre-training of large language model. So if you go to the if you check the Llama family of the models, so you'll find maybe hundreds of models, right? And some of the models are base models or pre-trained version of those models, and then you'll also find some instruct version of those models. So you you do pre-training, that is unsupervised learning, right? So that data set is not labeled, that is totally raw data. So you used a raw data and then you pre-trained the model, right? So once you are done with the pre-training part, so you have to fine-tune the model. So the reason of fine-tuning is, you wanted to align the model with the human preferences, or maybe you wanted to align the model with according to your use case, right? So you'll create a labeled data set. So you'll have prompts in one column, completions in second column. So let's say query in one column, and then the answer of the query in the second column. That is your labeled data set. And then you'll convert that data set into a format which you can use for the fine tuning of the large language model. So you can use the standard chat template. So if I go to, let me show you the chat template. So you can search this chat template, Llama model, Microsoft. I think, let me go to this. So these are the chat templates. So here you can see. So you have user, and then you have the content of the user. You have role assistant, then you have the content of the assistant, then you have again role user, and then you have the content of the user. So here you can see you have some special tokens. So these are the special tokens which we use normally in chat templates, where we can define, hey, within this instruction token, you have the instruction from the user maybe, right? And then after this particular instruction token, you maybe have the instruction from the assistant, and then there could be end of the sentence EOS type of tokens in your chat template. So here you can see this is the chat template. So you have user, and then you have assistant, and then again you have user. So this type of chat templates are standard chat templates, which you can see. You can simply search these chat templates. So then you can simply use this method, apply chat template, whenever you wanted to convert your messages or convert your simply CSV dataset into a proper chat template, which you can use to convert your data into a format which can be used for the large language model for the fine tuning. Let me go back to the presentation again. So you have to define the scope, then you have to select the model. So how you can select the model? This is again very important part. So for example, let's say if you wanted to fine tune Llama 70 bill model, so that is a very big model. Or if you wanted to fine tune 405 bill model, so that is again a very big model. So you cannot fine tune these models by using a single GPU. So you have to use multiple GPUs. So there is a thumb rule. So thumb rule is, so let's say for one bill model, you need 4 gigs of memory. So that is a simple thumb rule. You can find the calculations, mathematical calculations related to this on internet. I can provide you some links after this workshop, so you can understand how we can compute the resource requirement to fine tune the large language model. So so when you have to choose the model, you have to have a clear understanding of resources which you are going to use to fine tune that particular model. So let's say for one bill, you need 4 gigs of memory just to load the model in the memory, right? And if the model is 70 bill model, so just for the inference, this is not for the fine tuning, this is for the inference. So for fine tuning, you need different resources. For inference, you need different resources. So fine tuning is very resource intensive task. So if you are using a model and you wanted to deploy that model for the inference on a private server, you need 4 gigs of memory for 1 billion parameter. So if the model is 70 bill parameter, so you need 140 plus 140. So you can do the maths here. That is 280. So you need 280 gigs of memory just to load that model for the inference. So the highest GPU which is right now available in the industry, that is 80 gigs. Just a second, guys. Yeah. So that is 80 gigs. So V100, that is 80 gigs. So you need at least 4 V100 GPUs for the inference of 70 bill model, right? And this is when you have to load a full precision model. So there are different precision standards which are being used in the industry right now. So the full precision is FP32 and the half precision is FP16, but the new standard is FP16, which is considered as full precision. So if you quantize that model, so you can reduce a little bit of memory footprint. So this is just for the inference. And there are many techniques which you can use to optimize this inference, like KV caching and speculative decoding. You can search these terms or this jargon on internet to understand what is KV caching. So to understand what is KV caching, you have to have very good understanding of transformer architecture first of all. So what are the keys? What are the values in the transformer architecture? What is the embedding? What is the tokenizer? What is the positional embeddings? So you have to have very good understanding of these things, right? So for the fine tuning, so the thumb rule is for 1 gigs you need, sorry, for 1 bill parameter, if you want to fine tune 1 billion parameter, you need 18 GB of VRAM of a GPU, right? So if you want to fine tune a full precision 70 bill model, so you can simply multiply 18 by 70 if your model is not quantized. So let's say if your model is quantized, you can multiply 17 by 14.5. So that is a thumb rule. And if your model is quantized, then you can save some memory footprints. You can reduce some memory footprints and you can save some memory, right? So there are packages which we use for fine tuning. So for example, there is a one famous package by Hugging Face, that is SFT. So on top of that, some companies or some companies build some open source packages which we are going to use today, that is Unsloth. So if you are using Unsloth, so you can reduce the memory footprint by around 56 to 60% while fine tuning a model. So that is the reason you have to choose this model very carefully according to the resources you have to fine tune this model. So in today's workshop, we'll try to fine tune 1 bill model, Llama 1 bill model, or we can go with Phi 3.5 or Phi 4. And after choosing the model, you have 3 options. So prompt engineering, what is prompt engineering? You can if you can align your model by providing few examples, then you don't need to fine tune the model. So let's say by providing 5, 6, or 10 examples, I can align the model according to my use case. So let's say I wanted my LLM to give me a structured output. So this is a very critical task. So because LLMs are not trained to provide structured outputs. Let's say you want to get a very structured output, then you maybe can use Pydantic with your large language model, and you can also provide few examples to your large language model, and then you can align your model for the structured output. But still, if you are not able to align your model by using prompt engineering, then you have to go with the fine tuning, right? And after fine tuning, there is a third task that is aligned with human feedback. So in this step, we normally use RLHF techniques. So RLHF is reinforcement learning with human feedback. I'll explain how RLHF works as well, but our main focus will be fine tuning today. And then we'll evaluate the model, and then we'll optimize the model and deploy model for the inference. So for inference, you can use deploy LM, or you can use VLLM type of packages. And then you can, use this model to build your LLM powered applications. So this is the life cycle of generative AI. So I'll explain this aligning with human feedback later in this session. So if you have any question, you can ask. Otherwise, I can, proceed with the session.
Please, if you have any question, raise your hand. Otherwise, we can continue with the session.
Yes. So because we have short time, we have to start this workshop as well. So I'll quickly explain, some important features.
I think we could continue.
Okay, sure. So this is simply in context learning, that is zero shot inference. So what is zero shot inference? It's very important to understand this jargon. So zero shot inference is you are just asking a simple question. You are throwing a question to LLM, and LLM is answering your question. That is zero shot. You are not providing any context or any example to the LLM. So let's say if my prompt is classify the review, I loved this DVD, and then the LLM should answer the sentiment. So I have not provided any example to my model. I am simply throwing my question to the LLM, and LLM is providing me the answer. So that is zero shot. So this is again zero shot. So we also call this in context learning, ISL. Here again, I have not provided any example to the LLM. So this was a large model. So let's say I tested this example by using 70 bill model, and 70 bill model, gave me a very good answer, right? But I don't have resources to deploy or to use a 70 bill model in production. So let's say my boss asked me to go with a smaller model. So I tested the same example with maybe 13 bill model, 7 bill model, 8 bill model, 2 bill, 3 bill, 1 bill model. So let's say I tested this same example with 1 billion parameter model, but that 1 billion parameter model is not providing me correct answer, right? So this is the reason I have to go with either few shots, or even still, if I'm not getting correct answer after providing few shots, I have to go with fine tuning. Fine tuning could be like, it could be a knowledge distillation, or it could be a LoRa adapter. So what is the difference between knowledge distillation and LoRa adapter? That is very important to understand. So knowledge distillation is full fine tuning of the large language model. So let's say if you are fine tuning 1 billion model, 1 billion parameter model, that is Llama 3.11 bill parameter model. So in knowledge distillation, you have to update all the weights of this particular model. So that is knowledge distillation by using any teacher model. So the teacher model could be your 70 bill model, and this 1 bill model could be your student model, and you wanted to distill the knowledge of that bigger model to your smaller model, right? But you have to update all the weights of this smaller model. That is knowledge distillation. But how LoRa fine tuning is different from knowledge distillation, that is very interesting. So in LoRa fine tuning, we are not updating all the weights of the model. We are just updating some weights of the model. So let's say in LoRa fine tuning, what we do is we simply decompose the matrix. So let's say you have 1 billion parameter matrix, and you created 2 ranks or 3 ranks or 4 ranks, 8 ranks, 16 ranks, 32 ranks vector. So those vectors can be used for the LoRa adapter fine tuning. Those are very lightweight vectors. And when you have to use these LoRa adapters for the inference, so you cannot use isolated LoRa adapters for the inference. So you have to load your base model first. Then on top of base model, you'll patch or you'll attach or you'll merge your LoRa adapter, maybe dynamically, maybe one time. So you can merge the LoRa adapter with your base model. That is one option. And second option is, let's say you have hundreds of LoRa adapters. You can simply upload a LoRa adapter dynamically on the fly, and then you can patch that LoRa adapter with your base model, and then you can perform the inference. So there are pros and cons of both knowledge distillation fine tuning and LoRa adapter fine tuning. So in knowledge distillation, we because we are updating all the weights of the model, so we may face catastrophic forgetting. So catastrophic forgetting is, so your model will not be, so let's say you have fine-tuned your model just to answer your customers' queries, right? And you prepared a data set of maybe 1,000, 2,000, or 5,000 rows. It could be a synthetic data set, or it could be an actual data set of FAQs. And you used that data set to fine tune your model by using knowledge distillation. You updated all the weights of the model. Then your model will always answer uh, according to your data set, which you have used in the training. It will not be able to generalize in reasoning tasks, in complex reasoning tasks, or in any other task which is not like the data set which you have used in the fine tuning, right? So that is catastrophic forgetting. And if we are using LoRa adapter, so LoRa adapter will not update the existing weights of your original model. So it will freeze all the weights of your original model. It will just, train few ranks, few new ranks on top of that base model. And then your reasoning ability of the model will not be degenerated, or will not be, your model will not face any kind of catastrophic forgetting. There could be a minimal difference between the, base model and base model plus LoRa adapter. There could be a very minimal difference between that. So, so let me skim through these quickly, these slides. So I'll stop if something is important which I wanted to share. So these are the things which I have already shared, like you have a pre-trained large language model. Then you have a task specific examples. So in task specific examples, it could be a CSV file, right? So the CSV file can be look like something like this. So it could be like query and then answer of the query. So let's say, hey, I wanted to cancel my line, right? And the answer could be, how can I help you not retain? Like this could be the answer. So you can have a CSV like this. So once you have the CSV like this, so the steps are like this. So if you wanted to go with the, custom training. So you should have a CSV like this, okay? And then you should have a CSV like this, and then you have to convert this CSV to JSON-L files. Okay, so JSON-L file will look something like this. So it will be like customer, and this is the customer query, and then agent, and this is the agent response. Right, so the JSON will look something like this. So this is your CSV file. You have to convert your CSV file into JSON lines. So JSON lines are nothing but you could have multiple JSON lines, right? So second row, third row, fourth row, right? And then from this JSON lines, or what you can do is you could have a CSV. You can convert this CSV into JSON lines. Then you have to convert this JSON lines into a arrow format. This is Hugging Face standard format. This is step number 3. So this is step number 1. Sorry. So this is step number 1. This is step number 2. This is step number 3. And in step number 4 is nothing but, load the data set and tokenize the data set. Sorry, not tokenize. Load the data set and apply chat template. Okay, so this is step number 4, right? Step number 1, again, this is step number 1. Just a second. Step number 1, and this is step number 2. This is step number 3, and this is step number 4, right? Step 1, step 2, step 3, step 4. Once you applied the chat template, and then what you have to do is you have to tokenize the data using model tokenizer. You have to remember these steps. Okay, so this is step number, just a second, whatever. So you have to tokenize here. So CSV, then CSV to JSON lines, then to arrow format, or you can go other way around. If you have JSON lines, you can also convert JSON lines to standard arrow format. You can convert your CSV to standard arrow format. But to apply the chat template, you need JSON lines. So from this arrow format, when you load the dataset by using dataset library of Hugging Face, so it will convert your arrow format dataset into a JSON lines. So how this arrow format is different from CSV. It is lossless compression. That's it. So let's say you have CSV file, 1 gig memory. The file size is, let's say, 1 gig. You can convert the same file to an arrow format, and that arrow format will be of maybe few hundred MBs. So this is lossless compression. So it will not, it will not remove some important information from your data. It will just compress that information. That's why we call it lossless compression. So from this arrow format, you have to load the dataset by using datasets library it will convert again into JSON lines, and then we'll apply the chat template on top of that. And then you have to tokenize the data. So tokenizing is nothing. Let's say, so you have this sentence, hey, I wanted to cancel my line. So in your vocabulary, or the tokenizer of your vocabulary, so let's say 10 represents A, or let's say 111 represents I. Let's say 14 represents wanted. Let's say 5 represents to. Let's say 656 represents cancel line. So it will just convert your textual data into numerical data. So that is tokenization. So once you are done with this tokenization part, then you can simply instantiate your trainer, and then you can simply start your training. So you have 2 or 3 options to train these models for the fine tuning task. So you can go with Python code by using directly SFT library, or you can go with the Onslaught, that is wrapper on top of the SFT library, or you can go with auto trainer, which is also available in Hugging Face. So you can use that UI to fine tune your model. So once you have tokenized your data set, so you have to instantiate your trainer. So let's say this is your trainer, and once your trainer is instantiated, you have to you'll get a LoRa adapter. Okay, so you can use this LoRa adapter with your base model. So this is the part. This is important part. So once you are done with the LoRa adapter fine tuning, so you can, option 1 is merge LoRa adapter with your base model, or oh God, second option is load dynamically on the fly LoRa adapter with base model. So you have these options. So it depends. So let's say if you are merging the LoRa adapter with your base model, uh, then your base model will get updated. So if you don't want to merge LoRa adapter with your base model, you can simply load LoRa adapter on the fly. So let's say you wanted to use one single model in your company, but you have different tasks. So there are 3 or 4 chatbots which are being used in your company. So one chatbot is for supply chain, one chatbot is for production, one chatbot is for sales, one chatbot is for R&D department, right? So you have a separate LoRa adapter for R&D adapter. You have a separate LoRa adapter for sales department. You have a separate LoRa adapter for supply chain department, and you have a separate LoRa adapter for production department. Then in this case, you'll not merge your adapters with your base model, because you have to load LoRa adapter on the fly with the base model. Whenever the query is related to sales, you'll load the sales related LoRa adapter on the fly, and you'll patch it with your base model. Whenever the query is related to production, you'll upload the production related LoRa adapter on the fly, and you'll patch it with the base model, and then you'll answer that query, right? And then you'll offload that LoRa adapter. So this is how you can load and offload LoRa adapters. So if you have any question, you can ask. Otherwise, Asma, can you please share that notebook with everyone so we can start working on that?
All right, we're going to share it on the chat.
Sure. Let me know when you guys are ready. Please open this notebook and let me know when you are ready.
انا ندرج معاهم شي شويه. الوغ الشباب غادي نعطيوكم واحد البي دي اف اللي كان زيد يبارطاجي منه داكوغ وبارطاجيت معكم اسماء نوت بوك في جوجل كولاب. هذا هو الوركشوب اللي غادي نديرو. دونك غنعطيوكم دو ريسورس ومن بعد غنبارطاجيو معكم في الجروب وغنخليهم حتى في لا ديسكريبسيون ديال الفيديو اللي كاين ديجا دابا في يوتيوب. ملي بغا يتسال غيبقى مسجل باش اللي بغا يراجع من بعد يشوف هادشي. المهم نكملو. ثانك يو.
So we could continue, Zaid. We have shared the link on the chat.
Okay, sure. So you can also join in the Discord group of Onslaught, and you can ask any question in general channel. So let's say if you are using Onslaught and you are facing any issue, you can go to this Discord channel, and in general you can paste your question and you can tag their developers to ask any question. So Onslaught, if you go to Hugging Face Onslaught, right? So this is Onslaught AI. So if you see like here in organizations cards, Onslaught, I love Onslaught because what they have done is they have reduced the memory footprint required to fine tune these models, and the performance is 2x faster. So let's say if it is taking 5 hours or 10 hours or 24 hours to fine tune a model by using SFT library, but by using Onslaught, you can reduce that time like to 8 hours if it is taking 24 hours, right? And if it is taking 8 hours, you can reduce it to 2 to 3 hours. And it is, for example, if by using SFT library, so you need for full precision 8-bill model. So let's say if you need, so let me do some calculations here. So if you are using SFT, so for 1 bill you need 18. For 8 bill you need 8 multiplied by 18. That is 114. If your model is quantized, you need 8 multiplied by 14. Sorry, 14.5. That is 116. So this is the memory you need to fine tune a half precision, that is FP16 model, 8-bill parameter model. But if you are using Onslaught, you'll reduce this memory footprint by, so it is different for each model. So on average, it's 50%. So when I fine-tuned 8-bill model, so for SFT, it was taking around 1116 gigs of memory because I was having only one GPU, that is A100. So in A100, we have VRAM of 80 GB. So it was taking around 56 GBs, right? So that is, so you can fine tune by using single GPU. So it was taking 56 GBs of the memory. So let's proceed with the notebook. So you can either run this line, pip install Onslaught, and then this line to install the latest version of the Onslaught and Onslaught Zoo. So under the hood, if you'll install this Onslaught package, so let me show you. Or you can simply go with pip install Onslaught. You can simply go with this one. So if you'll install this, so first of all, you have to go to this runtime. From this runtime, you'll see the option of change runtime. So in change runtime, you'll get the free access of T4 GPU or TPU. So don't go with the GPU version. You can go with the T4 GPU. Don't go with CPU, right? And you can also select Python or R. So we are using Python 3 and we are using T4 GPU, right? So you can change the runtime. And when you'll install this, it will take some time. Let's say I'm going to install. So it will install multiple libraries under the hood. It will install Torch. it will install transformer, it will install bits and bytes, it will install TRL, it will install many other libraries which are required to load the model from the Hugging Face, to load the tokenizer from the Hugging Face, to process the data which is in Hugging Face standard format, and perform all kind of operations. So you don't need to install anything else apart from this particular library. So you can simply install this and you are ready to go. So let me show you under the hood what other libraries it is installing. So once we are done with this installation, we can run this simple command pip freeze. Just a second. So the packages are being installed. You can also run this command. So all the packages, because I have already installed it, so that's why it is not taking much time. Might be take 5 minutes or 10 minutes for you. So if I'll run this pip freeze command. So under the hood, it installed all these libraries, tokenizer, toml, all these libraries. So it also installed xformers, if I can see that. Yes, xformer. So it also installed WebSockets. Yes, installed Torch Vision, Torch Summary, Torch Audio, Torch. So for the progress bar and TensorFlow packages, right? So it installed everything which you need to. It also installed scikit-learn. So it installed everything which you need. So it installed different. So what are these libraries? So these libraries are nothing but, so let me show you. I don't know if I'm connected with the server. So just a second. No, it will not. I'm not connected with VPN, so it will not connect with. So if you run command like this, like NVIDIA, let me run this command in here. Let me run this command here. So if you run this command NVIDIA SMI, so because NVIDIA GPU is not, let me show you the output of this command. NVIDIA SMI. So if you'll run this command, if you have the GPU, you'll get an output like this. So in this output, if you can see, if I can zoom the screen, so you'll see two important things, driver version and CUDA version, right? So these two things should be aligned and compatible with each other. So not all the CUDA versions are compatible with all the driver versions. Not all the driver versions are compatible with CUDA version. You can go to, you can go to the website of NVIDIA and you can check what are the compatible versions of CUDA and drivers. So this is I think the latest version, that is 12.0. So this is the compatible driver version with this particular CUDA version. So that is why you see these libraries for different CUDA variants, right? So you have installed these libraries. So I have opened, the chat. Sorry, just a sec. Yeah. So this is the Hugging Face page of Unsloth AI. So you can see different models and you can see collections. So let's say if you wanted to go Llama 3.21 build, you can find the model here. So I'll also show you one important thing here. Just let me find the one. So this is the Llama 3.23 build instruct variant. So this is the fine-tuned version of the Llama 3. So if you go to any model, let's say go to the model. So you can see here. So this model is fine-tuned version, right? Of which model? This is the gated model. This is the base model. Meta Llama 3.23 build instruct version. So on top of that, they fine-tuned a model, and this is the model. And there are 231 adopters as well, right? 1110 fine-tuned model by using this particular model, or by using this model, this fine-tuned model. This is the complete tree. 4 merge models, 41 different variants of the quantizations applied on this model. So if you go to this website again, God, where is that? Just a look. So you can see some models have BNB 4-bit, some models have GGUF, and some models have BF16. So these are the different, so GGUF, BNB, BF16, and AWQ. These are the different, different variants of quantizations, or different, you can say, So this model is not gated model. So that's why I'm not providing any Hugging Face token here. So it will return me tokenizer and it will return me the model. So you'll see something like this. You'll see the model shift tensor files are being uploaded. So this is 1 GB, 1 GB in size. So I have loaded the shift tensor files. I have mapped those shift tensor files. So this is all done, behind the curtain. So you uploaded the model, you uploaded the tokenizer. So it could be, so some models, so let's say large models could be in different shards, shard 1, shard 2, shard 3, shard 4. So this model is in single shard. I mean, not sharded model. This is, so I have a single safe tensor files. So let's say if you have 4 safe tensor files, so it means, let's say if you are loading 8-bill model, so the 8-bill model will have maybe 3 shards, maybe 4 shards of different sizes, 2 GB, 3 GB, 2.7 GB. So shards like this. So I have uploaded the model. Then this is the standard code provided by Unsloth. You can use standard code, but you have to understand few things. So in fast language model, so you have to use this method get-peft model. So within get-peft model, you have to provide your base model, which you wanted to use. So what is this model? This model is nothing but this model, which I have uploaded. This model, Unsloth model. So you have to provide your model. Then this is nothing but rank. So you can go with rank 8. You can go with rank. So what is rank? I'm not going into the details of ranks. So this is simple linear algebra. You can go to Khan's Academy and you can check videos of matrices and the ranks of the matrices, or the matrix decomposition. So what is matrix decomposition? So this is the rank. So this is a hyperparameter. In layman terms, you can start with 8, you can go up till 128 and so on and so forth, right? Right now we are using 16. So if you are changing, so if you are increasing the number of ranks, you are retaining maximum information of the model. So if you are going with rank 8, it means you are training very less parameters. If you are going with rank 16, it means you are training, more parameters than rank 8. If you are increasing the ranks, it means you are training more parameters. So if you're choosing 128, it means you're using maximum parameters, trainable parameters, right? So by increasing the number of ranks, you are trying to retain the maximum information of the model. And then you have few target modules like Q projection, K projection, V projection, output projection, gate projection, up projection, down projection. So these three are important. So this is query projection, key projection, and value projection. So what are the queries? What are the keys? What are the values? I don't think so that we'll be able to cover this within this short span of time. You can read about transformer architecture to understand what is key, what are the queries, what are the values. So these are the target modules which we wanted to target for the fine tuning. Then LoRa alpha, it's again a hyperparameter dropout. To avoid overfitting, you can change the dropout value for the optimization. So this is also very important hyperparameter. Use RS LoRa. So you can read about RS LoRa on Hugging Face. You'll find some articles. So what is RS LoRa? So while fine tuning, many people observe this behavior even if we are increasing ranks. So theoretically it's true that whenever you are increasing ranks, you are trying to retain maximum variance or the maximum information of the model. But let's say with rank 8, I am getting, let's say just for an example, I'm getting 62% accuracy, right? And I increased rank from 8 to 16, still I'm getting 61% accuracy. Then I again increased rank from 16 to 32, but still I'm getting 61% accuracy. And I keep increasing. Let's say I reached to 128, but still I'm getting 61% accuracy. So theoretically, this is counterintuitive. This is not true. This should not be happening. I am increasing the rank size, so the accuracy should be increasing because I'm trying to retain maximum information of the model, right? So that's why we have to use this stabilized LoRa. So if you wanted to increase the accuracy by increasing number of ranks, you can make it true. Use RS LoRa, right? And then you can run this. So this is your model is, updated with all these target variables like query key value layers, and with all the config you have you have updated here. So this is the important part. So this is one we were talking about. This is the chat template. So you can use the so what is good about Unsloth is they have already defined a chat template for Llama or for any model under the hood. You can simply use that standard chat template. So right now here in this example, we are using alpaca dataset. So that dataset is being downloaded from here, from Hugging Face. So if you go to just a second. Yeah. So this is the dataset. So this is the dataset, and you can go to use dataset. You can use dataset libraries, pandas library, whatever it is. So if you go to the dataset library, this is how you can, load this dataset. So this is in arrow format. So you have output, and then you have instruction like give 3 tips for staying healthy. So it is providing you the 3 tips. So it is a very long data set, or very, very big data set. So you have like thousands of records, 100,000 of records. So we'll just slice this data for our use case just to show you the process, and you can use the larger data set later on. So it will load this data set, and then in this map function, what we are trying to achieve here is, in this map function, we are simply mapping our chat template with this data set. And then at the end, we are also providing end of sentence token. So see, this is very important. So what is written here, must add end of sentence token, otherwise your generation will go on forever and ever and ever. So you have to define the end of sentence token. So whenever the model see this end of sentence token, it will stop generating, text. So this is the step you can do. So this step is nothing, but you started with loading this model. These 2 lines are standard lines you can find from the Hugging Face, and then you mapped this data set with your chat template. So let me run this again. So you mapped this data set. So once you map this data set, so see, this is not the actual data set. This is, so if we go to this instruction, we now use alpaca dataset from Yahama, which is filtered version of 52K of the original alpaca data. So original alpaca dataset is very large dataset. So from that dataset, this particular user, sliced 52K instructions from that dataset. So we have 52K or 51,760 records. So we have these column: output column, input column, instruction column. So you are providing input, you are providing instruction to answer your question, and maybe you are providing text. So no, this text is separate column. So you are providing input, you are providing instruction, and this should be the output. And this text is nothing but the combination of all. So basically we provide the combination of everything to the model. So so as you can see in this format, we'll have our instruction, we'll have our input, and we'll have our response. So these columns are combined in a single text, string. So we'll provide this single text string every time to the model. So model will understand from that text string. So hey, this is the instruction, hey, this is the input, and hey, this is the response. So model will understand what is instruction, what is input, and what is response from this chat template. So that is the text column. So if you can see here, this is empty list in this function. So we are using this zip method. So what is this zip method? This zip method is nothing but if you wanted to zip 2, 3, 4 things, or if you want to concatenate 2, 3, 4 things like this. So if you go to the, uh, documentation, you can see you can zip everything in a tuple. So you have 3 things in a tuple: A00, B11, C22. So if you wanted to zip, instruction, input, and output, you can use this zip method. It will zip everything, convert into a chat template, and provide you in this text column. Then you'll return this text column, right? So this is that text column. So for this exercise, I have just sliced 1000 records from these 51,000 records. I'm not going with these all 51,000 records. It will take too much time. So you have, I'm sure you have the similar Jupyter notebook, because Unslot provides many notebooks, but the standard is same, right? So you can slice this 1000 records. Then this is the standard code. So I'm not going into the details of this code. So this is your task to search about these hyperparameters. So it will take maybe days, maybe weeks, or maybe at least 1 month to understand, or maybe 2 months to understand all these hyperparameters, right? So you have, it's nothing but it's configuration of the SFT trainer, standard SFT trainer of Hugging Face. So you are importing this standard SFT trainer from this TRL library, and then you are instantiating it, and you are just providing the configuration. So this is the standard configuration of Unslot library. You don't need to change anything, just instantiate it. So this is the optimizer. So there are many optimizers like GrokFast, Atom, many optimizers. So standard is Atom, which is being used in industry right now. So you have to provide your output directory where you wanted to store your output. So you have to instantiate your trainer. So you have instantiated your trainer. You can run this cell or you can ignore this. So if you will run this cell, it will provide you how many, what is the status of your GPU. So I'm having 14 gigs of memory, which I can use to fine tune this model. So once your trainer is instantiated, this is your trainer, you can simply run trainer.train, right? So it will tell you have, so device mapping is by default. So if you have 2 GPUs, it will map. So right now you cannot use Unslot for multiple GPUs. This is also one of the takeaways. So Unslot is not providing multi-GPU fine-tuning. It is providing 1 GPU fine-tuning. So for multi-GPU fine-tuning, you can go with the deep speed or other packages, or maybe SFT trainer. So the loss is decreasing. Right? So once you are done with this part, you can simply, for inference, you can load your model, and then you can load the tokenizer, and then you can start asking question. So I'll be sharing a code with you guys for. Let me share just a second. So till this step we are good, right? Come on. Okay. So once you train the model, so let's say my model is trained. So what you can do is you can run this command to save your LoRa adapters. So you have to run two commands. One is model.save pre-trained, and second is tokenizer.save pre-trained. This is the custom string. You can name whatever you want. So I named it like adopter underscore bad one as a model and adopter underscore bad one as a tokenizer. So what it will do is it will save your tokenizer or the saved tensor files within your directory. Then you can use peft package, and let's say now I wanted to use this adapter. You can use this peft package. By using this peft package, you can so see, I have used BNB 4-bit model, BNB Llama 3.1 8-bit BNB 4-bit model for fine tuning. But see here, I'm using AWQ model for the inference, right? Just for the testing. So I have uploaded my base model, right? From pre-trained auto model for causal LLM. So this is the package of transformer. And then auto tokenizer is also one of the method of this transformer library. So by using auto tokenizer, this class, I'm getting this, I'm calling this function from pre-trained, and I'm uploading, I'm loading tokenizer. So I have loaded my base model. I have loaded my tokenizer. I'm done with the training. I have saved tensor files of my LoRa adapter within the same directory by running this command, right? Now I wanted to test this LoRa adapter. So for testing, I have to load the base model. Then I have to load the tokenizer. So I have loaded the base model. I have loaded the tokenizer. So once I'm done with this, so I have to patch this LoRa adapter with my base model. So that is important. So how can I patch this? So it's simple. So you have from peft model. So this is peft model. So you have imported peft model from the peft library. So peft model dot from pre-trained, you provided base model, and then you'll provide the path of your LoRa adapter. So because this LoRa adapter is present within the same directory, that's why I'm providing this path. You can copy the path, or you can also upload this LoRa adapter on Hugging Face and you can provide the path. So you have to provide the path of your LoRa adapter. Then, so I'm naming it model B with LoRa. So it means I have patched my LoRa adapter with my base model. Then I'm performing some inferences. So like, the base model was not behaving like a good agent, but when I fine-tuned it, and I have attached it with this model, so it is providing me very good answers, right? So it is providing me very good answers. So you can see, I completely understand, I respect your decision, however, I would love the opportunity to speak with your manager, can provide tailored solution for your solution, blah 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 blah. So this is how we can, like, so this is the bad model. So I have trained two adapters. So bad adapter is saying, I mean, I could, but it's like not gonna be worth your time. So this is how you can train your adapters, and you can patch it and you can use it. So last but not least, so till this point, if you have any question, you can ask. Otherwise, I'm moving to the Hella Swag part quickly. Done. Thank you. So I'll be sharing Python code with you for these type of evaluation. But let me tell you how these evaluations are being done. So there are, if you go to any model like Phi3 benchmarks, go to Microsoft. Come on, yeah. So in the table, you can see categories, you can see benchmarks, you can see different models. So within categories, you have like popular, aggregated benchmark. These are different data sets. You have reasoning. These are the different data sets. Within reasoning, you can see Hella Swag. So 5 shots means you provided five examples to the model. 0 shot means you have not provided any example to the model, right? So this is one of the data set, Hella Swag. How you can use Hella Swag? Set looks like this. So so within Helastack, you have JSON lines. So this is one JSON line just for the example. So we have to test. So we have trained LoRa adapter. We have to test if the model's reasoning ability is degenerated after training LoRa adapter or not. Right? This is what we have to test. So I'll run this test on Helastack dataset by using base model. Then I'll run this same test on Helastack dataset by using base model patched with LoRa adapter, and then I'll compare. Right? So how can I do that? Right? So this is the comparison. This is the comparison. Right? So I'm not going to this detail. So there is some information which I want to share because that is my company specific information. So what is this? So this is one JSON line example. So in example, you have CTX. So CTX is nothing but context. So context is a lady walks to barbell. She bends down and grabs the pole, the lady. So we have to complete this sentence, right? So to complete this sentence, we have 4 endings, options, and then we have label. So the true ending is this one, right? But we have options. So what we'll be doing? We'll be concatenating or we'll be patching each ending with this line. Like we'll start with the lady swings the land in her arms, and then we'll calculate the loss. Then we'll attach this ending here, like the lady pulls the barbell forward, and then we'll calculate the loss. Then we'll attach this ending, then we'll attach this ending. So the one ending with the minimum loss will be considered as a model's prediction, right? So if model prediction is exactly same with the actual label, then the accuracy is 100%, otherwise 0, right? And then we'll also calculate Rouge 1, Rouge 2, and Rouge L. You can search what is Rouge score. This is your task, right? So let me show you how it works. So we loaded the model, loaded the LoRa adapter. So we started evaluating. So for first example, swings and lands in her arms. So this was the first ending. We attached this ending at the end of our sentence, and the loss was 4.65. Then we attached second ending, and the loss was 4.2. Then we attached third ending, and the loss was 3.9. Then yes. So then we attached, so ending 1, 2, 3, 4. So the minimum loss is with this particular ending, and the result is a lady walks to a barbell, she bends down and grabs the pole, the lady. So the correct ending is this one, and predicted ending is this one. So prediction is correct, yes, and this is all the scores. So for last ending, the Rouge 1, Rouge 2, Rouge L, and accuracy is 100%. So this is how we calculate. This is how we do the benchmarking, right? So you have to read few things about these benchmarks. So I'll try to share a notebook for this benchmarking as well. So that's it about today's session, guys. If you have any question, please feel free to ask. I'm going to stop sharing my screen, and we have, let's say, 5 minutes for the Q&A session. Otherwise, you can try this fine tuning with different data sets.
Thank you so much, Zaid. If anyone has a question, please write it down in the chat or raise your hand if you want to speak. Go ahead, Pat.
Yes.
Yeah, go ahead, that's it.
Yeah, please go ahead. Please ask your question. I thought there is some question in the chat.
Yeah. So my question is, why was the Phi 3.5 mini model chosen for fine tuning in this workshop, and what computational resources are recommended for this process? Should we have the GPU or a computer, a laptop with, for example, CPU can do the job for us?
Yeah, that's a very good question. So by the way, I sorry for the misunderstanding. In my notebook, I have used Llama 3.21 bill parameter model. You can use any model. So the reason of choosing Phi 3.5 or Llama 1 bill model was because we were using free, version of Google Colab. So within free version of Google Colab, you can access T4 GPU. So the T4 GPU comes with the 14 GB of VRAM, right? So for one bill parameter, you need 4 GB of VRAM. So yes, if you have 32 GB or 16 GB of RAM within your local system, you can go accordingly. So for one for one bill parameter model, you can fine tune it on your local system if you have 16 GB or at least 32 GB of RAM. Otherwise, in free Google Colab, you have T4 and you have 14 gigs VRAM, right? So you cannot fine tune larger models. So you have to go with paid version of Google Colab. A, B, you can rent out some GPUs by using maybe Run Pod or maybe any cloud instances.
So the Google Colab is the best fit for us. It's more good for example, Hugging Face is not good for anything.
I mean, Google Colab is one option. You can go with Run Pod. So within Run Pod, you can choose GPU of your choice, and it will provide you the instance of Jupyter Notebook. So that Jupyter Notebook will be attached with that GPU, and you can use that as well. So it is your choice. You can go with AWS, you can go with Google Cloud, you can go with Databricks, you can go with Azure, or even if you have GPU in your local machine, you can use that. But Google Colab, Google Pro version is not stable. So let's say, so I have faced these issues. So this is very important to understand. So let's say if I'm training my model for 10 epochs and it is taking 7 hours or 8 hours, right? My data set is big. Even I'm using Google Colab Pro version, which is paid version, right? So if there is some issue with your internet, your training will stop. You have to restart it again. So I don't recommend Google Colab for big data sets or for large number of epochs and for yes, any question? Khalil?
Yes, Khalil, you raised your hand.
Thanks.
You have access to the microphone.
Okay.
Sana, April.
Hello all. Thank you, Zaid, for this beautiful workshop, and Baha for helping us meet this beautiful guy. My question is, what's the best option to deploy this model and the needed infra to have multi-user instance to use this?
So, sir, actually, these models. So, if you use any large language models, you don't need to write code for multi-processing or multi-threading. So the architectures of these models will cater this if you are sending 100 or 1,000 of requests. And the second question is related to infrastructure. So as I have already mentioned, for the inference, if you have one bill parameter model, you need 4 gigs of the memory. So let's say you have 8 bill model. So I'm writing this in chat. So 8 multiplied by 4 is equal to 32 gigs of VRAM of GPU. And options are, one option is deploy LM, second option is VLLM. So these packages, you can search these packages, you can use. Why VLLM? They are using KV caching. So what is KV caching? This is what you have to search. So they're using KV caching, speculative or continuous decoding or speculative decoding. I'm not sure. I need to check this. Speculative decoding and continuous decoding. So these are little bit advanced topics. So, but you can read about it. What is KV caching? What is speculative decoding? And how VLLM solved this problem. And I can recommend some courses as well. Just a second. So there is a free course on deep learning that is efficiently serving LLMs. Yes, you should check this course. And I'm sharing. Yes. So yes. So you should check this course. Within this course, you'll find many jargons like what is KV caching, what is speculative decoding, what is continuous batching. So then you can search about these topics, and you can see how like KV caching is being done in VLLM, how speculative decoding or continuous batching is done. So VLLM, like making it little faster, so reducing latency at the inference time. So that's why they are using KV caching. So I'll recommend you to use VLLM.
Okay, thank you.
No.
Sana, I guess you have a question.
Go, Sana.
Yes, hello everyone. Thank you, Zaid. Thank you, MDS members, for this rich content. So my first question is when to use PIFTs and when to use SFT trainer. Which one is better and in which use cases? And
So-
for the second, sorry, I have about 3 questions.
Sure.
If you may. Thank you so much. My second question is about the evaluation phase. So how does like 0 shots, 5 shots affect the model performance? And you mentioned at first that there is a method for the integration of human evaluation methods. So how we can integrate it in our fine-tuned models? And thank you so much.
Okay, so sorry, I forgot to explain the RLHF part. So I think we can have another session for RLHF. So that is a very detailed topic. So maybe next month we can have a session so there are some packages which you can use. So you can search about RLHF. So within RLHF, you have to have very good understanding what is reward model. So let me write this for you. So then I'll come to your second question. So for RLHF, so you have to understand what is reward model, right? What is reward model and how we train reward model. Train a reward model. Okay, and then you have to search what is PPO, proximal policy optimization, and what is scale divergence. I don't remember the spellings of scale divergence, so I'm writing it KD. So this is what you have to search for RLHF. So in RLHF, what we normally do is we have already a fine-tuned model, and we send the question to the fine-tuned model, and we have a preference data set. So preference data set is, for example, let's say your question, then your answer. So let's say you are asking same question from the model 5 times, right? And your model is providing you answer. Then from all these answers, you have a preferred answer. So let's say model provided you 5 answers. One of the answer is preferred answers. So that is manually annotated data. So this is what we call preference data set. So we are using that preference data set to train our reward model. So we are getting output from the fine-tuned model, and then we are assigning reward to the model. So if the reward is positive, we are not penalizing the model. If the reward is negative, we are penalizing the model to align with the human preferences. That is a very high level bird eye view of RLHF fine-tuning. So there are some advanced method of reinforcement learning without using reward model. So that is ORPO, and there is one other method. I forget the name, so I'll be sharing all these methods in our next session. So probably we can have another session maybe next month. So I have to see my schedule, so I'll share with the team so we can have the session on RLHF. And the second question is related to SFT trainer PEFT. So PEFT and SFT are same. PEFT and SFT are same, right? So PEFT is parameter efficient fine tuning, and Unsloth is a wrapper around PEFT. So under the hood, Unsloth is also using PEFT, but they have optimized some of the parameters for the faster training and for the less usage of the resources. That's it.
Okay, thank you so much.
No problem. So if I missed any of your questions, so pardon me, because there were 2-3 questions. So I think I have answered all of these questions. Anyone else? Otherwise, I think I have to drop within 1 or 2 minutes.
Do you have any questions, guys? Yes, Fahdi.
So, hi again. Hi, Zaid. I'm working on a project using Power BI with over 6 million rows of data sourced from multiple DBMS. And I'm to integrate generative AI for real-time insights and accurate response based on SQL data. So I have 3 key questions and objectives included to what is the best stack for fine-tuning and generative AI model with SQL data, ensuring efficient retrieval, processing and response accuracy, which deployment. No, sorry. Wait. So to make you in the case, should I use, for example, Olama for hosting, or implement, for example, use Olama and use, for example, Llama 3.3, or implement a custom LLM orchestrator, for example, Docker or MLflow, or build an open AI like dashboard with the API and token management, because I want to deploy in one server the LLM, the engine, and use it in other project, and how to communicate with them. Are there reliable open source solutions for an API dashboard, or should it be built manually with Fast API or Flask? So, as you know, the LLM, the data is not accurate. The generative data is not accurate for the RAG. So what I did, I make some multi-agents, one for generate SQL queries, and connect with the database for read them, and other agents for verify them. But every time the LLM generates me some random queries. So how can I be sure for that? Especially that is a prod project, and the tables we can find some nominations not correct for our case. Yeah,
so what is the model you are using in production?
Llama 3.3.
Llama 3.3, which variant?
The
8
base,
bill, 2 bill, 3 bill, 70 bill?
17, yeah.
70 bill. Okay, right. So see, I mean, I would highly recommend you to create a data set. I mean, what I understood from your question is, like, you can share the architecture diagram with me, and I can thoroughly check your architecture diagram, and I can recommend you the solutions, right? And one question which I understood from your discussion is, you wanted to generate SQL query on the fly, right? And right now your model is not generating right SQL queries. Correct me if I'm wrong.
Exactly. In every inference generates me something not the same, not
Yep,
the correct.
yep, yeah.
Yeah.
So that is the reason we go with the fine. So see, guys, so we can start with the few shots, and even if with few shots, if we are not able to generate right SQL queries, you have to go with the fine tuning. So for lightweight fine tuning, I would highly recommend you to train a LoRa adapter. So why LoRa adapter? Because you are not, fine tuning or updating all the weights of 70 bill model, which is very, very time and compute intensive, right? Time, compute, and cost intensive, right? So you can simply create a data set, and that data set with two columns. Column one is question like find me top 5 like slow moving products, let's say from the data set, sales data set. And the second column should be the SQL query, and that SQL query which can fetch the records from your database, relevant records from your database, right?
Yeah.
The SQL query could be a simple SQL query from one table. It could be a SQL query which is fetching records from multiple tables by using maybe joins. And it could be a more, complex query which is using maybe CTE and subqueries and joins and blah, 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 right? So you have to prepare a data set like this, and then simply follow the notebook which I have shared with you and train a LoRa adapter. Save the LoRa adapter, and whenever you wanted to use that LoRa adapter, you don't need to change the model in production. Use the same model in production. Just patch that LoRa adapter, which is very lightweight or few MBs, like which will consume few MBs, and that patch that fine-tuned LoRa adapter on top of the 70 bill base model, and it will start generating right SQL queries for you.
Yeah. Okay. So it's like you verify it manually. That's it. You train the LLM.
I mean, you have to create a data set. That's the only tricky part here. It
Yeah,
could
it's
be
like
a
the
manual creation. It could,
reinforcement learning based on human feedback.
yes. So I would recommend you to create 500 records. 500 to 1000 records are enough to fine tune a model. So
All right.
you can generate 500 or 1000 queries for your questions, and I'll guide you more about it. Don't worry. I mean, it's a very easy peasy task.
Yeah, yeah. And about the best MLOps architecture for production environments to
That
efficiently
is
manage
VLLM.
model
VL,
deployments, access,
that,
and
that is
what do
LM
you
deploy or
recommend?
VLLM. Yes, VLLM or LM deploy.
Yeah.
So
What?
yeah, you can simply Dockerize it, use that Docker image, and
Okay.
use VLLM or LM deploy to create an endpoint.
You don't recommend, for example, MLflow? No.
So MLflow is not for, I mean, deployment. MLflow is just you can use for the model registry. So you can, for example, let's say you have 500 examples. You have trained a LoRa adapter, and then you are storing that LoRa adapter in a model registry. So the purpose of using MLflow is just versioning different models in model registry. So let's say
Okay.
tomorrow you are
It's like
training new
GitHub.
model. Yeah, it's like GitHub. So because MLOps is three-dimensional, GitHub is just code versioning. MLOps is like model versioning, data versioning, and code versioning. So for code versioning, you are using GitHub. For model versioning, you are using MLflow or weights and biases, maybe MLflow. And for data versioning, you are using. So there is a package, I forget the name. That is.
Fast API? No.
No. So there is a package. I forget the name of that package which you use for the data versioning. So yeah, so MLflow is just for the model versioning.
All right. All right. Thank you. So
So
the
guys,
LLM and LM deploy is for have
yes,
access the API management. We can use these two
yes, for
technologies.
deployment, yes. For
Yeah, thank you.
deployment.
We have a last question. I think someone
Yes,
is raising the hand.
yes, please,
I
because I
guess
have to drop within
The
1 or
last
2
one.
minutes.
The last one.
Yeah, please go ahead.
Sure.
yes, Khalid.
Okay, Khalid.
I was trying to ask, uh, what are your recommendation for someone who's from a web development background and he wanna switch to AI fields? Is it recommended,
I mean,
or
yes,
what do you think?
it's recommended, but I mean, you have to set your preferences first, because in within AI you have like different 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 areas like in which
Yes,
you can
that's
excel, right? So I mean, it is recommended, but see, so there is a sky blue search and there is a ground level implementation. So if you wanted to if you wanted to like target the sky blue search, or sky blue research or R&D or pure AI, then uh, you have to have a very good understanding of mathematics, a like linear algebra, multivariate calculus, probability, statistics, blah 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 blah. Then you have to have very good understanding of basic ML, right? Traditional ML, statistical modeling, deep learning, neural networks, then transformer, and then these large language models. And if you want to become a citizen data scientist, or applied scientist, so you can just uh, you can start a project, you can start working on a project and just learn all the things related to that particular project or the models you are using in that particular project, because it's a
us.
very vast field, it's a very research intensive field. So it's a years of game. Like even after having 6 or 7 years of experience, I still feel that I have to learn so many things. So yeah, I mean,
Yeah,
it is recommended, but it depends.
yeah, because here in Morocco, I'm actually pursuing a master degree in web development, and I don't
Mhm.
know from here in 5 years, things gonna change. And in Morocco, like, do I have to switch up to another master degree or learn by
I mean, that's
myself
a very tricky question,
using?
man. That's a very tricky. See. I have seen people, they shifted from mechanical or electrical engineering background to data science or AI background. What they did is in Pakistan, they have done from top-notch universities. They have done masters from electrical or even in computer science. Then after a few years, they realized, okay, AI is very high, so you can get a very high paying job if you know about AI or data science. Then they went to US. They did degrees from the US, like University of Chicago, Stanford, and big colleges. So they did
Uh,
master's degree, and some of them are doing very well, some of them are still not doing very well. So I have seen many people with master's degree in data science, and they know nothing about data science. They cannot implement a simple use case. So it depends. I mean, master's degree is just a piece of paper which can make your resume looks little bit attractive.
yeah,
Other than that,
that's
or yes, after master's degree, if you pursue PhD, so that's interesting. If you pursue PhD, you are done with the PhD. You know very little about data science, but you know what is like decision tree, what is random forest, what is XGBoost, where I can apply classification, where I can apply regression. And you have done your PhD. You don't have any industry experience. You can become a practice head. You can become a CTO. So I have seen people like these in the industry as well, who don't know anything about data science. They have just done their PhD in AI ML, and they are working as a CTO or as a practice head. So I mean, it's again a very funny, very tricky, I mean, very tricky question. I don't have any certain answer about this question.
well. Thank you for at least giving me hints.
No problem. Thank you guys. Thank you. It
Thank,
was a very nice session. See you soon. Inshallah.
thank you so much, Zaid. You have
Allah
already
Hafiz.
exceeded the time. Thank you so much.
Thank you.
For the people in the meet, I will share with you a small quiz if you would love to participate. And also, I will share with you later on a link to a form to fill so that you could receive your own certificate. I've already added in the chat. So Asia, are you with me?
Yes. Can you hear me?
غادي نلعبوا
Yes.
Yes.
مرحبا.
Okay.
زيد
Hello everyone.
ثانك يو زيد مشى
I guess.
مشى راه عنده موما جوج دابا واقيلا
I guess عندهم جوج ديال الصباح. Okay.
So hello everyone.
No,
So I guess it's time for a lot of fun. I guess so. We're gonna play a game, actually a quiz, an easy quiz, just to have fun together, and pretty much to see how much we've learned and test our knowledge. So let's play quiz. I want all of you please to participate and join in. Koshar, can you proceed to the next slide?
okay, but can you see the
Yes,
presentation first?
Yes.
This is the code.
Yeah, so you can just visit the Menti website, or just you can enter the code 43915224, or just you can scan the QR code to directly participate. So please, guys, I want all of you to join, so we can have fun together. So I guess we're gonna wait for 5 minutes, so all of them can participate.
Yes. Can you send the link in the chat, Asia?
Okay. All right.
And while we are waiting for the rest, please fill out the form to receive your certificate later on.
بليز تشيك واش هاد اللينك هو اللي تيدخل لهاد اللعيبه. يس
Yes. So
هو هذا سي بون راه نحسو
Koshar, can you go to the next slide باش تشوف شحال.
Okay.
So we have 8 players. So we need more, please. First, 17. Okay.
17.
Yeah.
جاست 5 اللي داخلين. جايز دخلوا عافاكم.
Koshar, start already the quiz. Okay, let's start. Okay, the first question is an easy question. So what does
مازال ما داخلينش يلا سلام.
Koshar, you start.
نرجعوا.
I guess so.
اوكي.
Okay.
انا وركت عليها بزاف زعما ما ردتش البال.
عطاكم كلشي دخلوا ليا اللي لحنا في لو شات. نلعب لهم في الجروب.
اوكي. مازال كيبان بارطاجي؟
يس.
اوكي.
سعود وصلوا غير 15 بعد. 10 11 12 30 اللي معنا عافاكم دخلوا لديك اللي احنا نعاودو نلوحوها. هاو
راه it's so easy ما مشيت حاجة صعيب.
صافي نوصلوا ل 15 نبدا.
وما تنسوش تعملوا الفورميلا.
و don't share it with your friend. خمسطاش ما بغاتش تجي. دخلي تلعبي معنا انت اسيا.
already كنعرف لك لا ريبونس.
صافي نبداو.
صافي نبداو.
يلا سير. ما فهمتش.
because بديتي. It's okay. ندوز the next question. So have 15 players, 21 players. Okay, that's good. So, shall we start? نبدأ.
اوكي سير عطا.
Okay, c'est la question.
اي الثانية فين مشات؟
كنت نكرر جوج مرات.
It's okay. Can you clone the game? هادي ما تيطلع لنا والو حنا.
واش ما تيبانش لكم بارطاج؟
ما تيبانلناش فين نختاروا.
ما تيبانوش لا كيسيون كنت.
اوكي هي الكيستيون بدات.
Yeah.
So I'm going to read the question. So which components is often fine-tuned when using adapters and LLMs? Is it specific layers of the model, the entire model, the training dataset, or the optimizer? So actually, faster you respond, answer, so fast, more points you get. So you should be quick.
Okay.
Okay. So next.
ما تعطيناش سكور. It's okay. Next.
Okay, صافي read.
Yeah.
Okay, next question. What is the primary purpose of fine-tuning adapters in LLMs? To adapt the model to specific task, to remove unnecessary layers, to reduce model size.
I think حتى الاخر غادي يعطينا سكور. No?
Yeah, yes.
Yeah.
Okay.
Okay, 15 got it right. Okay, next. Okay, next question. I see you can read it.
Okay, which metric is commonly tracked during fine-tuning of adapters? Is it adapter storage size, dataset size, validation loss, or training duration?
Only 5 got it. Okay, next. Okay, ready? Okay. Go ahead, Asnam.
Okay, where's the function of adapter fusion is in LLM fine-tuning is compressing datasets, deleting unused
Adapters.
combining adapters for multitask learning.
Okay, the majority got it right. Okay, next. The last question.
This is the last question.
واقيلا هذا هو السبور ديك اللي كبيروا بزاف بابا نويل هو الاول.
Okay, last question. Yeah.
Okay, what is common method for version control and MLOps? Just type in the answer.
Git.
Yep, I guess this is the last question. So let's use the winner, the top performance.
خالد.
عندنا جوج خالد. هي صفار خالد.
شكون خالد؟
لا اكيد ماشي انا
واش خالد معنا في الميت يدوي.
شكون خالد؟ خالد
لا
البواري.
انا الثاني ما عرفتش انا واحد والله ما عرفتش انا. لا حيت انا ما عمري قريت LLM صراحه انا جاي من الويب ديف.
جو بونس راه معنا مي ما عرفتش عنده نيك نيم كولد ويند ولا شي حاجه.
ميبي
خير كربح هو كربحت انا صراحه.
كولد ويند يلا برافو كولد ويند تتصل بينا نعطيوك التيشيرت.
صافي فريمون هادشي كاين. واش عمرتو فورمولا؟
في الدوك كوين. Yeah, the link of the form. هذا. وشكرا.
Thank you.
وعام مباركة. ميوزك تاع نسيت بلاتي عافاكم نشتو الميوزك.
كايز ما تنساوش زعما فاش توصلكم لي سيرتيفيكات بارطاجيوهم وتاغيو MDS. ديجا عندكم لي ريزو سوسيو ديال MDS توكس في لينكدين ولا الاجندا اللي عندنا في فلوم ولا حتى لي جروب واتساب. راه ديجا صيفطت لكم اسماء كاع اللينكس. عندكم شي فيدباك شي كيستيون شي حاجه مرحبا. بالنسبه للناس اللي ديجا عمروا الفورمولار ديال الفالنتيرز المهم راه قريب ان شاء الله غندير لكم الاونبوردين. سو ستي تون.
يب so yeah, so thank you all for being part of today's workshop on fine-tuning generative AI models. I have covered some critical aspects of generative AI, from the fundamental of LLMs to practical fine-tuning techniques. I hope you are leaving with a deeper understanding of how to leverage these tools in your own projects and research. As we continue to push the boundaries of AI, remember that the world of data science and AI is ever evolving. The knowledge we gain today can shape the innovations of tomorrow. I encourage each of you to keep experimenting, learning, and collaborating within the MDS community. Our mission at MDS is to empower, share, and elevate the Moroccan tech ecosystem. And we are excited to have you as part of this journey. Keep pushing the boundaries of what's possible, and feel free to reach out for further discussions, collaborations, and knowledge exchange. Thank you once again for joining us, and we look forward to seeing you at our next events. Together, we are shaping the future of AI in Morocco and beyond. Stay curious, stay inspired, and let's make a lasting impact. Thank you very, very much. Now is the Ahidus part, and good night.